And this video is going to show a CMM inspection on this Flexure part. I have another copy of it here and you can look through it. These channels through the part are about 12 thousandths of an inch and they were cut with a wire EDM. The material is 6061 aluminum and it's been type 2 anodized black. This flexure is designed to move half a millimeter with 2.5 kilograms of force applied, and you can see the flexure ultimately bottoms out against the stop. And the weight or the mass applied matches the SolidWorks simulation pretty good. But anyway, to measure a part like this on a CMM a traditional touch-only CMM wouldn't be possible because the probe that you would need to get down into these holes, or the channels rather, is just too small. It would be about, it would need to probably be about 4 or 5 thousandths of an inch, but the smallest ruby that you can get is about 0.3 millimeters. So anyway, here's the drawing to give an idea of just some of the callouts on here. A lot of them are distances, sort of traditional distances. Four digits are plus or minus 1 thou. The rest of the part is basically plus and minus 4, with the exception of this true position callout of 4 thousandths true position, which is really kind of like plus or minus 1.5 thousandths in traditional tolerancing, and those are dowel pinholes. We'll go ahead and hit run on this. So the first thing that the machine does in the routine is to set a pretty high magnification and then to measure some points by focusing. And with it zoomed way in like that, you get a pretty accurate representation of the Z value. In this case it was 4 points there, and then that gets fit to a plane, which in the drawing is a datum plane. And here you can see the machine going around and gathering some data on various features. A lot of the part, because they're through features, are gathered with backlighting only. That gives a nice contrast. And some of the features had to be gathered using oblique lighting or coaxial lighting, like those two were the pinholes, which are blind holes. In this case, measuring a counterbore diameter where the bottom of the hole is blind, and also these internal radiuses around the through pocket in the middle. The features are larger than can fit on the field of view at one time, so the machine can gather several lines or arcs like it was showing there, and then you build those into a composite feature later. Which means that it combines all of the gathered points in the selected features to refit a nominal shape like a circle or an arc or a line. And here is the last sort of type of feature collection. The machine is going around and tracing the edges of these wire cut through slots. And so you can see it's going to gather about 3,000 points on this one. There's a similar through feature. There's 4 different total through features here, and you can see in the part the 4 starter holes You can see where the wire cut through the wall of the starter holes. And you need 4 independent contours to make up this particular flexure. And so we'll go around and gather a closed contour on those 4 different slots. So in total, it's something like 11 or 12,000 points, and you can use these points that are gathered here as a point cloud to do a cloud to CAD comparison and get an overall profile tolerance. Or maybe there were areas of the flexure that are very critical. You could tune your wire EDM program based on this cloud to CAD comparison. You can see that the step through the routine just never allows the field of view to move more than one whole frame, and it's able to pick up the edge since it's at a known place. It's done a good job of not getting confused and picking an edge that's like on the opposite side of the channel or on one of the other 4 contours. This would be the last of the 4 contours to gather the edge tracing data on. So that's the end of the routine, and it takes a few seconds to write all the data to some various output files. So once the measurement routine is complete, some of the things that you can do in this software, all these green features are the gathered data, and you can also show points, but there were quite a few of them, so it's cluttered. And you can also import a CAD model, in this case 2D DXF. And if we kind of zoom in, you can drive around. And for example, here is a location where the gathered profile is a little bit outside of the CAD, but just sort of qualitative in this particular software. You can export the raw data, which is like in this DAT file. So here's X, Y, and Z, just like a point cloud, and this is the type of data from the run that you can then import to a different software to view profile tolerances and cloud to CAD compare. And then it also outputs a sort of traditional CMM style report here, where these values, you know, they're 25% of the tolerance. And so if you find one that has like 4 pluses, it's pretty close to being out of tolerance. And if you find a value that has a numerical value here, for example, this one is 3/10,000ths of an inch out of tolerance. And some of the holes had the true position call out on them. And there was a flatness of the datum plane that we measured. And there's also like a z distance from the datum plane to another step that's in there. It's supposed to be 20 thou, and it's 19.6 thousandths. So you can see that the deviation is minus 4/10,000ths. But there's an update on sort of the state of metrology here using this video CMM.